In this video we're going to look at scientific notation to be used in terms of operations. And multiplication and division are quite straightforward, but addition and subtraction is quite mean to do by pen and paper methods. So in the booklet, in the module, we've talked about how to use calculator work. You're best to talk that over with your tutor if possible. But for the moment, we're just going to do this by pen and paper methods. So in this first one, we've got 5 times 10 to the 7 times by 3.2 times 10 to the negative 9. So we're going to regroup that as 5 times 3.2 times 10 to the 7 times 10 to the negative 9. Now 5 times 3.2 turns out to be 16 times by 10 to the 7 times 10 to the minus 9. You're multiplying numbers with the same base, so you add their exponents. 7 add negative 9 adds up to negative 2. But if you look at this answer is not in scientific notation, because 16, it shouldn't be 16, it should be 1.6. So we need to make an adjustment because of that. So this becomes 1.6 times 10 to the 1, that's just 16, times by 10 to the minus 2. So that's now 1.6 times 10 to the 1 plus negative 2, which is 1 take 2, which is negative 1. So our answer is 1.6 times 10 to the negative 1, or it's 0.16 if you were to change it back to an ordinary number. Now with the second one, the division, I think you should write that in fraction form. It just helps an awful lot. So 3.75 divided by 4.2, I'd expect you to use your calculator here, is 0.893 times by 10 to the negative 11 divided by 10 to the 7 is 10 to the negative 11. Subtract because it's division, and you've got positive 7 or just 7 there. So this is 0.893 times 10 to the negative 18. Now this isn't in scientific notation anymore because we don't have a number here between 1 and 9.99999. So to just deal with this is 8.93 times 10 to the minus 1. Then that's times by 10 to the negative 18. So altogether that's 8.93 times 10 to the negative 19. Now, in this question, we're going to do an addition and a subtraction. Now, you can't add or subtract numbers that aren't of the right place value. So what we need to do is we need to standardize these powers of 10. And that way, these numbers that are in front here will have the same place value. So this will, just a rule of thumb is to choose the biggest. And this will be, to write this as 10 to the power of 10 here, we will need to write, I don't think I've got space here anymore. Okay. We're going to make this 5.6. Now to get 10 to the 8, that involves 10 to the 10, it's 10 to the minus 2 times 10 to the 10. Alright, we wanted a 10 to the 10 here. We had to put in the 10 to the minus 2 to make sure that these two exponents multiplied to give 10 to the 8. So this is 4.7 times 10 to the 10 plus, now this part here is going to be 0.0 0.056 when you convert it back to a number. So move the decimal point 2 places, 1, 2, times 10 to the 10. Now you've got the two numbers in the same place value, you can actually add these. So it's going to be 4.756 times 10 to the 10. It's like saying we have 3,000 plus 2,000 is 5,000. The place value is 1,000, so here the place value is 10 to the 10, and we add these two together. Okay, we need to do the same with the next one. And we have, we're going to go this time, because we've got negative exponents, we're going to go with the -2. So we know that this is 3.72 times 10 to the -2 times 10 to the -2. So we're going for the largest exponent, which is -2. -2 is actually larger than -4. Subtract 8.21 times 10 to the -2. So we've now got the same place value with the -2, but we need to write this as 0.0372. Take away 8.21 times 10 to the -2. Now, you can think of this as being negative 8.21 plus this. You can set that out. We don't have the space here to do it, but that turns out to be negative 8.1728 times 10 to the -2. Okay, now moving on to the last one. We've got quite a big number and quite a small number, and we get working on the assumption that they won't fit into our calculators, but I suspect the second one will. So one option we've got is to say if our calculator can't do it, we put it into scientific notation and that will do it. So our number between 1 and 10 here is 1.95 times 10 to the, so 369 times 8.0 times 10 to the negative. We know it's negative, it's a small number, so the decimal point has gone 3678. So that's 8 by 10 to the -8. Now, multiplying it, 1.95 times 8 is 15.6 times 10 to the 9 plus -8, which is 15.6 times by 10 to the 1. But 15.6 is not in true scientific notation, but 1.56 times 10 to the 1 to compensate times 10 to the 1 is equal to 1.56 times 10 to the 2, or if we want to write that as a number in standard form, like the numbers we were given, this would be 156. So scientific notation is very important in science. I've done these calculations by pen and paper methods, but your calculator will do them as well. But it is particularly useful that you are able to convert between scientific notation and scientific notation and ordinary notation. That's the most important.